the negative 3 times the positive 1. Well, this is going to equal 2 minus a negative 3, which is actually plus 3, so that's going to equal 5. A whole bunch of your points for inverses are right there, just coming up with your D value. If you'd make a mistake here, like say you whittle this down, you go 2 minus 3 equals negative 1, at least I can see what you did, because that seems to be a common mistake on this one. People are coming up with their determinant equaling negative 1. But those people didn't usually show me work, and they just skipped right to the answer, which is a lot of points off because I don't know what you did. I'm not going to go through all the possible determinants that you could have come up with or what mistakes you did. All I'm going to come up with is the fact that you went from here to a wrong answer. And if it's horribly wrong where you didn't move stuff, then you just get a 0 on it. But just showing me this gets you a bunch more points, even if you made a mistake through it. All right, to actually do the inverse, we are going to flip that 2 and that 1. So that 2 and 1 are going to change places. And we're going to divide it by that D value. So that top left is going to become 1 divided by 5. That 1 switches place with the 2, so we got a 1 up there. And that makes my bottom right is going to be 2 divided by 5. The other diagonals, they do not switch places. All I do is change sign. So right now my top right is a negative 3, so it's going to become a positive 3 divided by 5. And finally that bottom left, since it's a positive 1, is going to become a negative 1 divided by 5, and that is all really the work I need to see. Your big step with work-wise is this one. Yeah, you can show me the steps where they flip and they change, and then you can do the division, but you can do it all in one step as well. This is as much work as you have to do on the test to show me that you know what you're doing. Questions on the bell work? Questions on the homework? Yeah.
You go with 3.
Yeah. Let's make sure I got the right one here. So number 3. We're just multiplying by the identity matrix, correct?
Yeah.
So this is all I was really looking for. I wasn't looking for a ton of work. All I'm really asking you to do is say, well, this is my A. Multiply it by the identity matrix. The identity matrix is 1's diagonally, 0's across. And I think you can do the rest in your head without doing a whole bunch of stuff, because it really is this row times this first column, and then we move to the next column. But let's just focus on this first column. All you have to keep straight in your head is 3 plus 0 plus 0 equals 3. I fully expect you can do that in your head. So you didn't have to write out that 3 plus 0 plus 0. If you did, good on you. But you really didn't have to. It could have been done in your head. Then we move to the next row, so on and so forth. And the whole point of these first two is, if I have a matrix and I multiply it by the identity matrix, you just come up with that regular matrix that you started with. All right, that's going to be important for today, because I'm just going to cross stuff out, and you have to realize that multiplying by the identity just turns out to itself. Questions on that? That led to question number 5, because question number 5 was multiplying the identity matrix by a matrix. You could have just written down the answer. So for number 4, this is all the work you'd have to do on the test, and you'd have it correct. I don't need to see anything. If I put this question on the test, or a bigger one, and you just write down your original matrix, that's all the work you had to do. I didn't need to see, circling stuff and actually see the multiplication. It's just going to multiply by the identity, comes out with the original matrix. That's all the work you need for the test. All right, other questions on the homework? No? Okay. Then today what we're going to do is we're going to talk about how can we use these inverses to actually solve systems of equation, because the bulk of what we're doing with matrices is how can I use these to solve systems of equation. More specifically, how can I relate that to a calculator? How can I plug a system of equations into a calculator and get an answer out? It's very important. When you get to higher level math classes, it's going to make your life a lot easier versus someone trying to solve it by substitution. You're just like, I'm just going to plug this into a matrix, and now I have the answer. So, if you remember when I talked about Gauss-Jordan elimination, I said you need to know what Gauss-Jordan elimination is. And that's because this is a completely new way to solve it. With Gauss-Jordan, when we put it into a matrix, we put it into one augmented matrix. When I ask you to solve it using inverses, you are going to use this matrix multiplication setup. And to set it up this way, we've done it in homeworks. But in short, all you're going to do is you're going to take those numbers that are out in front, so that's our A, B, C, D, and you're going to put it into one matrix. So this matrix is going to be A, B, C, D. Then you're going to take your variables in order in which they appear. So x appears first, so x is going to be on the top. Y comes second, so y is going to be next. If you had a z, you just add a z down here. And this is going to equal E times F. And if you very quickly think about it, well, if I do my row times my column, you have to write this down, we're just doing it kind of in our head. If we do row times column, I come up with A times X plus B times Y. Yeah, that's what I had here. If you did it with the next row, you'd have C times X, D times Y. You come up with the next one. So yeah, that is the exact same thing as the system that I wrote out. The major important one is, and how I'm going to stand it, I'm going to let M stand for that matrix that is A, B, C, D. Whenever I'm talking about M in this section, I'm talking about whatever numbers you have. So our A, B, C, D value. So anytime I talk about M, I'm talking about those numbers. So picture those as being numbers. Picture them as being like 2x plus 1y, 3x plus 1y. So those are just numbers sitting there. All right. The solution for A B, C, D times x, y equals EF is found simply by multiplying by the inverse of that matrix M. That's why we worked on solving inverses yesterday. Now we're going to use them to solve. Now let's see how that actually works. So we're going to multiply both sides of the equation by M inverse. In other words, the inverse of that matrix. I'm just going to let it stand by M inverse because I don't feel like writing that whole matrix with a negative sign above it. So I'm going to do N inverse of one side, which means I have to multiply the other side by M inverse. Here's where I want to make something very, very clear. Order matters. And we'll see it in the next problem. Your inverse has to come before that E and F value. So you're going to do your inverse times. It's always going to be in this order. Inverse first, this matrix second, always. If you flip it, you won't even be able to solve it. If you would take EF times M inverse, and I'll show you in the next one what would happen if we did that, you couldn't even solve it. So your M inverse has to come first. That inverse you're going to find is going to come first. Well, M inverse times M, that's what we really have here, because so this right here is actually M inverse times M, because that really is just my M. Anything multiplied by its inverse is just getting rid of it. That's our whole goal. So this is actually going to result in our identity matrix. This will result in our identity matrix. When I multiply a matrix times its inverse, the result is our identity matrix. In other words, it results in 1. Think of your identity matrix as just being 1 in a regular setup. Right? If I do 3x times 1/3, we just have 1x. Same thing's going to happen here. This inverse times e to f, these are going to change these numbers. That's all that happened here is just change those numbers. So I would actually do the multiplications, come up with 2 brand new numbers. Well, since this is just the inverse, this is the identity times x over y is just going to result in x over y. So if I multiply the inverse on both sides, I eliminate everything on the left side except for x and y, and I do this multiplication, we end up with jk. So in fact, we end up with our answer, with x equaling j and y equaling k. Thus, you could think about it this way. You can kind of think about it this way. If you're solving for x and y, all you have to do is take the inverse of m and multiply it by that other side of the equation. That would have been e and f. So you find your inverse, multiply it by these values, and you come up with your answer at the end. So really the big work you have to do is find an inverse, multiply it once, and you have your answer. I think even by hand, it's a little easier than Gauss-Jordan elimination with a nice 2x2 matrix. Let's actually put this in practice, because sometimes when you have a bunch of letters, it's just like, I don't know what's going on there. So let's do it in actual practice. I'm going to do this a little bit longer than you'd probably do it by hand on like a test, and I'll show you which steps you kind of skip or how to do it quicker. But we'll go through every single step. So the first thing you need to do is note that it says solve using inverses. If you would go on this problem and you'd skip that inverses thing and you actually use Gauss-Jordan elimination, you get 0 points for it, because I asked specifically for you to show me that you can do it with inverses, because you have to know the difference. It's kind of like if I asked for elimination and you use substitution. That isn't how I asked you to solve it. I get that in the real world, and I'll have problems that you can solve it however method you want to. I will have those, because I do think it's good that you just pick a method that you really like and you stick with it. But I do need to show, because that's my role as a teacher, to make sure you can do both methods before you pick one you're going to use every single time. So make sure you read inverses. We're going to set up a matrix. In Gaussian elimination, we use an augmented matrix. With these, we use the multiplication matrix. So it's going to look something like this. We are going to have our numbers. So I have 3, -2, 2, 1. We are going to multiply that by our variables in order in which they appear. They appear x first. We put x on top. We put y next. And now we just say that equals 4 over -3. That is just the setup. That is the setup. In order to do an inverse, I need to find the inverse next. So in the next step, we're going to go ahead and find the inverse of our matrix. Remember, we're using this one to find our inverse. This is going to be our inverse one, the 3, -2, 2, 1. This one right here is the one we care about doing the inverse of. So whenever I see inverse, I think find our determinant first. So our determinant is going to equal that 3 times 1 minus that -2 times 2, which is going to equal 3 times 1 is 3 minus a -4 actually turns to plus, so it's 3 plus 4 equals 7. So that means I'm going to write this all out. 2, 2, 1. That negative power just tells me I'm looking for the inverse. That's going to equal, we flip our 3 and 1 values. So we are going to have 1 over 7 in the top left. We're going to have 3 over 7 on the bottom right. The other diagonal, we don't flip them, we just change their signs. So although it's going to look like I flipped them, I am just changing this sign. It's probably the worst part when it just looks like we're not actually flipping them, we're just changing the sign. So this becomes a positive 2 over 7. And since we have a positive 2 on the left-hand side, it becomes a -2. Over 7. Our next step says to multiply each side by its inverse. So what we're going to do is we're going to take this inverse and we're going to plug it right here. Then we're going to take the inverse and plug it right smack dab in between here, because order matters, and I'll go over how important order is. So we're going to smack this right between here, and that's where we're going to write out the whole thing down here. I'm going to look at my notes because I can't keep track of all of those numbers without seeing it right in front of me. So we are going to have a little scribble mark. We are going to, let's do it in red. I'll do the inverse in red so we can see where I'm putting it. Let's make it 2. Okay. So we are just including that inverse. So we're going to have that 1 over 7, 2 over 7, -2 over 7, 3 over 7. We are going to multiply that by the whole left side. So that's going to be times that matrix 3, -2, 2, 1, times that x y. And that's going to equal, we're going to put this right in front. It has to go in front. So we're going to put that matrix 1, 7. We got that 1, 7. That doesn't look like a 7. I want to fix that a little bit. So we have 1 over 7. We have the 2 over 7. We have the negative 2 over 7. We have the 3 over 7. And we multiply that by the right side. My right side was at 4, negative 3. Now the whole part of multiplying by my inverse is I basically get rid of that thing that's in front of our x and y. Think about when I have 3x equals 9. I divide both things by 3 to get rid of the 3. That's what's happening here. This is the inverse of a matrix times a matrix. That just results in the identity matrix, which in matrix world is really just 1. So this right here just turns, to think about it, just turning to 1. It eliminates. So we're actually getting rid of this because it becomes our identity matrix. That is gone because it actually becomes our identity matrix. Which our identity matrix times x over y just becomes x and y. So we're actually just left with x and y on this side. On this side, we actually have to do the multiplication. We have to do the work on the right-hand side. So to do that work, we're just going to do row times column. So we have row times column. So our top is going to be 1/7 times 4, which is 4 over 7. Plus 2 times a negative 3 is a negative 6 over 7. And then we go to the next column, which is the negative 2 and 7. So we have negative 2 times 4, which is negative 8 over 7. Plus 3 times negative 3 is a negative 9 over 7. So this side actually becomes, 4 minus 6 is negative 2 over 7. And negative 8 minus 9 is negative 17 over 7. So in other words, all I have left right now, on the left-hand side is an identity matrix times x and y, so I'm just left with x over y. And that's going to equal, my right side ended up just being negative 2 over 7. Negative 17 over 7. So in fact, we just have x equals negative 2 over 7 and y equals negative 17 over 7. If I was solving this by hand, do you think I'd write this every single time, all of it, and showing that it crosses out? I probably wouldn't. I would probably just find my inverse. So I would probably skip all of this, and all I'd write down is x over y equals inverse times this, and do the work. So I would probably leave this off every single time, because every time this just cancels out. This turns to identity. So if given a problem, such as this, I might write this down, just so I know what matrix I have I'm working with. And then I would jump straight down to, hey, x over y equals inverse times this number. I also want to tell you how to do this on your calculator, because on your homework, part of the section says that you can use your calculator to solve it on your back half side. Let me hold off on doing those for right now. Let's flip back. Let's learn how to use our calculator to check our answers and actually do these problems. And we'll use our calculators to solve this particular problem. All right, we're going to use our calculators to solve this problem. So the big things you need to know is your matrix 3, negative 2, 2, 1, and your 4, negative 3. So we're going to go over to our calculator. Hopefully I got my calculator up. I do. You are just going to go to your matrix. Maybe. Nope. Okay, zoom in. Okay, so I'm going to my matrix screen. I'm going to go to my A. And if you hit A, nothing happens. That's probably the biggest mistake people make when they're trying to do matrices. What you need to do instead is you need to make sure you go over to your edit screen whenever you're trying to plug in numbers. That's when you come up with your matrix. So if you're just coming up with numbers that come on your home screen, it's probably because you didn't go to edit. So we're going to go over to edit. We're going to make sure it's a 2 by 2 because we're plugging in that matrix 3, -2, 2, 1. That is my M value. So once again, all I'm doing is I'm typing in the first part of my matrix. This 3, -2, 2, 1. I'm typing that into my calculator. Then I'm going to hit second quit. I always hit second quit. Otherwise, you might try to put something into a matrix wrong. Go back to your matrix screen. I'm going to edit. I'm going to go down to my B1. I don't care which one you put these in your matrices. Just remember which one is which. So I go over to my B. I'm going to make it a 2 by 1 matrix. That's going to be my 4, -3. In fact, because those are the only two matrices that have numbers in them. I have the 3, -2, 2, and 1, and I have the 4, -3. Now, to get my answer, all I need to do is say, well, the inverse of M times this matrix is going to be my answer. And we're going to make our calculator do all of it. We're going to make it find our inverse, and we're going to make it do the multiplication. And so our setup for that one is just going to be, I'm going to hit second quit to back out of there. I'm going to go back to my matrix screen, and I'm going to say I want matrix A. A is going to come first. So A is going to come first. So I have A. Now remember, you want the inverse of this. You want the inverse of it. Well, your inverse button is your matrix button. Jack, do you know where your inverse button is? I think it's right here. Okay. So you're just going to have A, hit the inverse button. Now it says, well, A inverse, our M inverse. And we're going to multiply that by our B value, or whatever matrix you have it in. Now we have basically M inverse times that other side of the equation is going to equal a bunch of decimals. This one you do have to, like this one you probably had to solve by hand, but you can check using your calculator. Well, if I look at my answer, we said that x equaled -2/7, so just plug in -2/7 and make sure it matches. So I do -2 divided by 7. Hey, those values match up. And then I'll just check my y value, which was supposed to be -17/7. That matches that bond value. I did everything correct. All right, it's just a quick check. Let your calculator make sure you have stuff correct. Questions on that? Yes?
How come you don't do the inverse of the other side, like to matrix B?
Why am I not doing the inverse of matrix B?
Yeah.
Because if I would do the, let me show you what you're kind of asking me to do. Nope. I need to bring that back up. It kicked me out of my session. So what you're kind of asking me to do is you're asking me to take the inverse of M and the inverse of EF. Do you get what I'm saying? No? All right. Let's bring up this screen. So this screen says the only inverse we need to take is our M value. My M value is the 3, -2, 2, 1. So our first step is to find the inverse and then multiply that inverse. So this is M inverse. This right here is M inverse, and this is just my 4, -3. So all I'm doing is M inverse times that 4, -3. Okay, yeah. So if I just go back to my screen, this is my A inverse is actually my M inverse times my B value. My B value is just those numbers. So you should only have one inverse. And it should always be set up this way where you have A inverse times B. And the reason why that order definitely matters, if you were checking your multiplication. So let me check to see if we can do this multiplication real quick. So I have 2 times 2 equals 2 times 1. I'm allowed to do this multiplication. If you would change the order, if you would have put this first and multiplied by the inverse, you'd have a 2 by 1 times a 2 by 2. You couldn't even do the multiplication. So if you're solving using inverses, and your answer is, I can't do it, it just means you put them out of order. Inverse first, your numbers second. Questions on that? All right, so let's look at our homework really quick. So on our homework, and I'll quickly flash some answers. This is kind of what I expect for work from you. And you can definitely do more than this, but this is kind of the minimal amount of work I want to see on your sheet. So I'm just looking at the first one. Don't quickly scramble it down, just kind of, this is all the information I should be able to see, especially on your test. I should be able to see that you came up with an original matrix, and you took the inverse of it. All right, so you have a matrix, and you go ahead and find the inverse of it. And then you should just set up that, in fact, it's the inverse times that other matrix. So that was that -3, -6, that was the other side. And that's going to equal your answer. All right, this is the minimal amount of work I should see on yours. I should see you find an inverse, multiply that inverse by that matrix, which is just your answers, the -3, -6. What you get out is your answer. On the back-hand side, it says you are allowed to use your calculator to check your answers. What I should see minimally on yours, I actually did them by hand, so if you want to do it by hand, awesome. At a minimum, I should see what your M equals, what your M inverse equals. You can let your calculator do that. And then basically what you multiplied. You can let your calculator do all of the work, but you should still write down the key information. I just don't need to see the work on how you calculated. I should see the key steps. Any questions on that? So I should still see the key steps even though you're using your calculator. But you can let it do the heavy lifting. Questions? Are we good? All right, let's go ahead and get started. If you're not sure what I'm talking about, what information you need on, just ask me. While you're working on, just say, is this enough information? I'll say yay or nay. I'm really prepping you